Good morning, scholars. I got to school this morning and realized that I forgot to make the video for 5.3, which is the lesson that I'm teaching today in class. So I'm going to make it right now, which means I may be a little bit late to office hours, but we'll see how it goes. All right, so matrices. Matrices are a way of organizing a set of numbers into a grid. So it looks like an Excel spreadsheet or a Google sheet or a table with multiple columns and multiple rows. So a matrix, again, it's just an organizational system for a set of numbers that could represent almost anything. So when we have a matrix, we always label it by how big it is, and that means how many rows and how many columns. So the size of a matrix is always going to be the number of rows by the number of columns. So rows are the horizontal ones and columns are the vertical ones. Okay? So for example, if I made a set of brackets and I wrote the numbers 2, 0, -1, 5, 1/3, 6, 2, 0, 0.3, 2/7, 1, and 10. Okay? That matrix has 12 numbers in it. It has 3 rows and it has 4 columns. And so we would say this is a 3 by 4 matrix. And each one of the numbers is considered an entry. And there's just space in between them. There's not commas or anything like that. So you just have to make sure you write it in such a way that you can tell the difference between each entry. And so, for example, this entry right here would be the entry that's in row 3, column 3. And so sometimes people will say that that is entry, and they'll put a little 3, 3, like a subscript. So that one would be in the, it's in the second row. How about that? It's in the second row, third column. And so that would be entry A sub 2, 3. And that's just how you can decide where something is. So for example, if I ask you, what is the number that is in the third row, fourth column? You would go, okay, down to the third row, that's right here. The fourth column, that's right here. So where do those meet? That's right here. That would be the entry in the third row, fourth column. So you have entry, let me change colors here. You have entry 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, and so forth. Okay, so again, a matrix can represent a lot of different things. It could represent how much you sold of different items on different days of a product at a store. It would be a way of keeping track of your inventory. It could be a way of listing different times of races that you were in. Different races, different days, or something like that. It could be anything. And this is how a computer stores information. It puts it into a matrix, and so all the information is in a certain location, and that's how you can retrieve it from your computer. So if we have matrices holding all of these numbers and they represent things, then we need to have a way of doing math with them, adding them, subtracting them, multiplying them, and dividing them. And it's pretty easy, okay? To be able to add two matrices together, first of all, they have to be the same size. Oh, and by the way, you can also have a matrix that's really small. Oftentimes we'll label a matrix with a capital letter. So let's say that matrix A was this matrix right here, 1, 7, -10. Okay, that is a 3 by 1 matrix, and it's just got 3 rows and 1 column. You could even have a matrix that was 1 by 1. It seems kind of silly to have a matrix that's 1 by 1, but you could have a matrix. And you can have matrix that is square, that has the same dimensions, both directions. So this would be like a 2 by 2 matrix, 5, 0, 0, 7, something like that. Okay, so matrices come in all sizes. So if you're going to add two matrices together, so if you wanted to add matrix A plus matrix B, first of all, they would have to be the same size. So the example that I gave of matrix A and matrix B right above there, you could not add those together. It wouldn't be possible. But if you have two matrices that are the same size, you can either add them or subtract them just by adding the components that match up. So let's make another example. Let's do matrix A. Let's make it 2, 5, 0, 3. And then matrix B, let's make it 6, -1, 1, 5. Okay? I don't know why I picked the numbers I do. If I wanted to add the two matrices together, because they're the same size, I just add the components that are in the same spot. So I would add the 2 and the 6 to get the entry that goes in the first row, first column. And I would add the 1 and, the negative 1 and the 5 to get the next one. So that would be 4. And then I would add 0 and 1 and get 1, and I would add 3 and 5 and get 8. Super, super easy. Subtraction, same thing. They have to be the same size, and you just subtract the components. So don't forget to subtract every single number. So this time it would be 2 minus 6, 5 minus negative 1, 0 minus 1, and 3 minus 5. Easy enough, right? Okay, so that's adding and subtracting. I'm going to skip to scalar multiplication. Scalar multiplication is where you take a matrix and you multiply it by a constant. Okay, so some number that you want to multiply times the entire matrix, and that is exactly what you do. For example, if you wanted to do 5 times matrix A, you would literally take the number 5 and distribute it to every single component in that matrix. So 5 times the first row, first column component, 5 times the first row, second column, 5 times 0 for that second row, first column, and 5 times 3 for the last entry. So that's called scalar multiplication. It's just multiplying a constant times a matrix, which you multiply the constant times every single number in the matrix. Okay, so that's adding, subtracting, and scalar multiplication. The next thing we do is multiplying together two matrices. Multiplying together two matrices is tricky, okay? When you want to multiply matrix A times matrix B, the first thing you need to know is they do not need to be the same size. In fact, sometimes two matrices that are the same size cannot be multiplied together. It depends. So for matrix A and matrix B to be able to be multiplied together, let's say that you have rows and columns for matrix A, and for matrix B you have, let's call it P and Q for its rows and columns. To be able to multiply matrix A times matrix B, these two numbers have to match. Now, what are those two numbers? It's the number of columns in the first matrix. It has to match the number of rows in the second matrix. And if you reverse the order of the multiplication, it's going to change that relationship, so it may not work in reverse order. So multiplication of matrices is not commutative, which is totally different than anything else we've ever studied in math. Matrix multiplication is not commutative, which means you can't reverse the order like you can in regular multiplication. Doesn't matter if you multiply 5 times 7 or 7 times 5, you get the same thing. Not true with matrix multiplication. Okay, so let's take our A and B that we have right here. We do have A and B being the same size. Okay, remember I came up with an A and B that were both 2 by 2. And if you see A times B, a 2 by 2 and a 2 by 2, those are going to be multipliable because those middle numbers match up. What I was talking about when it wouldn't work would be like if you had a 2 by 4 matrix and then you had a 3 by 4 matrix. These numbers don't match up right here, so this would not be possible for us to multiply. But our A and B are multipliable, so let me go ahead and write them down again up here. I'll use the same matrices. 2, 5, 0, 3. That's matrix A. And we want to multiply it times matrix B. And matrix B was 6, negative 1, 1, 5. Okay, I love teaching matrix multiplication, but I've learned that it's easier to show you how to do it than to tell you in steps. So, how you multiply two matrices together is, first of all, the size of the matrix that you're going to get for your answer is going to be the size of the dimensions that are on the outer edge of the two that you're multiplying together. So let me show you what I mean. This is a 2 by 2, and this is a 2 by 2. These numbers match up, so we're good to go. And the size of the resulting matrix is going to be these two numbers, so 2 by 2. So this is the size of the product. The size of the product is 2 by 2. All right, so I'm going to make a 2 by 2 matrix over here for my answer. This is going to be A times B. But how to get that answer? All right, here's where it gets tricky. To find the first number in our product matrix, we need to multiply the numbers in the first row of the first matrix times the numbers in the first column of the second matrix. And we do that entry by entry, and then we add together the products. Okay, let me show you what I'm talking about. So to get this first number right here in the answer, again, I'm going for this number right here. I need to multiply the first row times the first column. And I'm going to do it one entry at a time. So I'm going to start with the first one in the first row, which is a 2, and I'm going to multiply it times the first number in the first column of the second matrix, which is 6. So I'm going to go 2 times 6 plus, now I'm going to go to the second number, which is a 5, and I'm going to multiply 5 times the second number in the second column, so 5 times 1. 2 times 6 plus 5 times 1 would be 12 plus 5. That's going to give me 17. So 17 is what goes right there. Okay, now to get the number in the second spot, I'm going to do the same thing, but this time I'm going to use the second column and the first row. Because again, I'm multiplying to find the number that goes in the first row, second column of the product matrix. So this time I'm going to go 2 times -1 plus 5 times 5. So first number times first number, second number times second number. And then I add together those products. So I get -2 plus 25, so I get 23. So 23 is what goes right here. Okay, next number I'm trying to get is in the second row, first column. So to get it, I'm going to multiply the second row times the first column. Second row times the first column. Our colors are going to get really messy here. Oh, that's what I was worried about. It's going to turn black. Okay, let's see if I can start over here. There we go. Okay, so I'm trying to get this number right here. It's in the second row, first column, so I'm going to multiply second row times first column. So I'm going to go 0 times 6 plus 3 times 1. That's going to give me 3. Okay, for my last entry, I need to multiply the second row times the second column, because I'm trying to get the number that goes right here, which is the second row, second column. So I'm going to go first number, 0, times first number in the column, so 0 times -1, plus second number times second number, 3 times 5. So I'm going to get 15. And that's my product. That is A times B. If we reverse the order and we did B times A, we would get a different answer. That's a weird thing about matrix multiplication. Okay, so as you can tell, it gets complicated pretty quickly with matrices. Imagine if I had a 3 by 3 or an even bigger matrix that I wanted to multiply. So the nice thing is that most graphing calculators come with a matrix feature. So you should be able to do matrix math on your calculator. If you're using a TI-84, there's a button in the first column. It's the second function of the inverse button, and it pulls up a matrix menu. You have the names of the matrix, you have math that you can do with a matrix, and you have editing the matrix. So to enter the numbers for a matrix, you're going to go to the edit menu, and when you push enter, it's going to ask you to give the dimensions of the matrix. So what size matrix do you have? And so this is a 2 by 2, right? So I'm going to enter that this matrix, I'm going to try doing this one on my calculator. It's a 2 by 2 matrix. And then after I enter 2 by 2 for the dimensions, I enter the numbers one at a time, pushing enter after each one. And then you can fill the matrix with entries. So you can do that, and then you can use your calculator to do the matrix multiplication. So what you'll do is when you're on a blank screen, you're going to say matrix, names, and then go with your arrow key to whatever matrix it is you want to multiply or add or whatever, and then do the math, and then pull up the other matrix that you want to multiply by or add or whatever. And the calculator will tell you if the dimensions aren't correct. Like I'm trying right now to multiply a 2 by 2 times a 3 by 1. It doesn't work. It says dimension mismatch. So the calculator will tell you if you don't have the right size dimensions to be able to do matrix multiplication or addition or subtraction. So that's all we're going to do is matrix multiplication, addition and subtraction, and then scalar multiplication. The real reason we wanted to teach you about matrices is because this chapter is about systems of equations, and matrices are super useful for solving a system of equations. Now you guys are pretty good at solving 2 variable systems of equations. We practiced that earlier in the week. But what about last year when we did 3 variable situations, okay? 3 equations with 3 variables. It was quite a process to solve a system that had 3 equations and 3 variables. So, for example, this is something that I taught you to solve last year. X minus 4y plus 3z equals 5. Negative x plus 3y minus z equals negative 3. And 2x minus 4z equals 6. Notice I left a space because there was no y there, so I'm actually going to put plus 0y just to hold the space there. Okay, so last year I taught you how to solve these types of systems of 3 equations with 3 variables, and the way I taught you to do it was you start off with 3 variables, 3 equations, and you use elimination to get it down to 2 equations with 2 variables. So you basically get rid of either the x, the y, or the z. And then you do it again, get rid of either the x or the y, whatever's left, and then you'll have just 1 equation with 1 variable. Plug that back in. Once you get that, plug that back in along with the first one you found, and you'll have x, y, and z. So it was quite a process to find the solution x, comma, y, comma, z. And it's still a process, but it turns out we can use matrices to do this. The way that you do it is you set up a matrix called the coefficient matrix. Now the coefficient is all the numbers that are out in front. Forget about the x's and the y's and the z's, just the numbers that are out in front. So that's what we're going to call our coefficient matrix. So that's going to be 1, negative 4, 3, negative 1, 3, negative 1, 2, 0, negative 4. So this is the coefficient matrix. And then you're going to set up a secondary matrix right next to it that's the variable matrix. And in this case we have 3 variables, x, y, and z. So this is a 3 by 3, and if you multiply it times this 3 by 1, you get what we have for the first part of this problem. All of the equations with their coefficients and their variables. And then what does it equal? Well, it equals the answer matrix. 5, negative 3, and 6. So basically you have A times B equals C. A is the coefficient matrix, B is the variable matrix, and C is the answer. I shouldn't say answers. Constants? Let's say constants. Because the answers is what we're trying to find. We're trying to find the solution to this system of equations, the point that works, the xyz point that works in all 3 of these equations, if there is such a point. All right, so if we set it up like this, it's kind of cool because to solve for x, y, and z, we've been solving for variables for a long time. We basically need to get rid of this right here. So I know it's putting it all into this big chunk, but this is how it works. So if we want to get rid of it, we need to get rid of matrix A. So in math, whenever we want to get rid of something, we use the inverse operation. So if there is such a thing as the inverse of matrix A, we can use that to get rid of matrix A and have the answers x, y, and z. So think of it this way. You've got matrix A times matrix B equals matrix C. To get rid of matrix A, I'm going to multiply by what is called the inverse of matrix A. It's the opposite of matrix A. It's the matrix that makes matrix A go away. Just like when you have 5x equals 25, you divide by 5 on both sides because the inverse of multiplying by 5 is dividing by 5. If you had x plus 3 equals 17, you would get rid of the plus 3 by doing the inverse of adding 3, which is subtracting 3. So to get rid of a matrix, we're going to use the inverse matrix, and the symbol for that is an A with a negative 1. We're going to multiply the inverse matrix times matrix A, and those are going to cancel out. But whatever I do to one side, I have to do to the other. So I'm going to multiply the other side by the inverse of matrix A. So my answer matrix, my variable matrix, x, y, and z, is going to equal the inverse of matrix A times matrix C, which was the constants matrix. So I need to be able to find the inverse of matrix A. Well, you can find the inverse of matrix A by hand, but it is a giant pain in the butt. So I'm going to show you how to do it on your calculator. If you can enter matrix A in your calculator, then your calculator can find the inverse of matrix A and multiply it times matrix C. Notice the order, again, will have to be exactly correct or this won't work, because matrix multiplication is very specific about the order to get those dimensions matching up right. So you're definitely going to have to multiply matrix A inverse times matrix C. So on your calculator, you're going to enter matrix A, which I think I already did. Okay, matrix A is a 3 by 3 matrix. And then matrix B, you don't have to enter. And then matrix C, you're going to enter, which is a 3 by 1 matrix. Okay? And remember, the size of the answer matrix is always the outer dimensions there. Okay, if you do that, your calculator, if you multiply matrix A, and then find the name matrix A, take the inverse, and then multiply it times matrix B, or sorry, matrix C, find C in your list, and then multiply those together, you're going to get the answer matrix. And so it turns out on your calculator, it's going to show it to you as a matrix. It's going to show it like this. Matrix B is going to be 7, 2, and 2. Basically, 7, 2, and 2. That's your X, that's your Y, and that's your Z. Way easier than the technique that I taught you last year. If you don't have a graphing calculator, you're going to have to do all of this by hand, and that's okay. It's doable by hand. You're not going to be able to find the inverse. I haven't taught you how to do that, so you're going to have to do solving these systems the old way that I taught you last year. Okay, there are situations where you get no solution to some of these systems or infinite number of solutions. If you come across that where you get like 5 equals 0, that's going to be a no solution situation. And if you come across something where you get, I'm trying to think, for an infinite solutions one, you're going to find that there are lots of examples, so you're going to get something like 7 equals 7 or something like that. And that's going to be infinite solutions if you're doing it by hand. Your calculator will tell you if there's no solution if you're doing it using a calculator. All right, I think that's it. This was a lot. It's our last lesson for this semester, other than the one that you'll watch with a video, a YouTube video, and a Google quiz, which you'll do the last week of school. So, all right, I'm going to sign out.